Hello everyone, hope you have watched the previous video solution of CPET 2020 questions. If you haven't watched, then check out the link given in the description. And in this video, I am going to discuss all the questions and answers of CPET 2020. So let's get started. First question is, catalytic reduction of thiophene with H2 and Raney nickel forms what? N-butane, tetrahydrothiophene, thiophene or 2-thionyl nickel. See, this is our thiophene. It has one sulfur atom. So upon treatment with Raney nickel, this is the reduction reaction and all the double bonds will be removed here. So here we have 2 double bonds and 4 carbon atoms. So the product will be N-butane. We'll get one saturated alkane. So option A will be the right one. Question number 2. Hydrogenation of benzoyl chloride in presence of palladium on BaSO4 gives what? Benzyl alcohol, benzaldehyde, benzoic acid or phenol. If you have this reagent PD on BaSO4, that means it is nothing but the Rosenmund reduction reaction. So Rosenmund reduction is benzoyl chloride upon treatment with BaSO4 and on hydrogenation will form benzaldehyde. So option B is our right answer. Cycloalkanes are isomeric with olefins, alkynes, alkadines or all the above. See, it is asking about isomer, that means two compounds having same chemical formula. Okay, so the general formula for cycloalkane is CnH2n and the general formula for olefins, that is alkene, CnH2n. So option A will be the right answer. On the other hand, alkynes and alkadines, which have the chemical formula CnH2n minus 2. A compound with molecular formula C7H16 shows optical isomerism. The compound will be 2,2-dimethylpentane, 3-methylhexane, 2,3-dimethylpentane or none of these. See, a compound is optically active. Okay, that means it can rotate plane polarized light, and it is optically active means as at least one chiral carbon atom. What is chiral carbon atom? Chiral carbon means it should be connected to 4 different groups or 4 different atoms. Okay, so you have to find out the chiral carbon atom in all these compounds. In option A, this carbon is attached to 3-methyl group. That means it is not chiral. And in option B, this carbon is attached to 2-methyl group, one hydrogen, and this one is another group. So it is also not chiral carbon atom. But in option C, we have one chiral atom over here. This is the chiral carbon atom. It is connected to this group, methyl group, and one hydrogen atom. So it is optically active and it will show optical isomerism. Okay, option C will be the right one. Question number 5. What characteristics at best common to both cis-2-butene and trans-2-butene? Boiling point, dipole moment, heat of hydrogenation or product of hydrogenation. See, if you have two isomer, that is cis and trans, that means two enantiomer, they have same chemical properties, but their physical properties is always different. So this is our cis-2-butene and this is trans-2-butene. Okay, CH3 are on the same side and here CH3 and CH are trans-2. Okay, this compound is polar and here our mu, that is dipole moment, is greater than 0, but it is non-polar and dipole moment is roughly equal to 0. It has high boiling point and it has low boiling point. Cis-2-butene has high heat of hydrogenation. On the other hand, trans-2-butene has low heat of hydrogenation. but their product of hydrogenation when treating with H2 and platinum form butane, okay, N-butane, and here also we can get N-butane. So product of hydrogenation is same in both the cases. Reason of the loss of optical activity of lactic acid when OH group is changed by H is that asymmetry of the molecule is destroyed, symmetry of the molecule is destroyed, structural change occurs, or spatial arrangement is changed. See, this is our lactic acid. Okay, it is 4 different groups. That means this is our chiral carbon or asymmetric carbon. But when this OH group is replaced by hydrogen atom, then it forms propionic acid, okay, which has no chiral center. That means it has no asymmetric center. So asymmetry of the molecule is destroyed and lactic acid loses its optical activity. Option A will be the right one. An alkane with molecular weight 72 upon chlorination gives only one monochlorination product. The alkane is 2-methyl butane, N-pentane, 2,2-dimethyl propane, or all of the three above. See, this is our 2-methyl butane. It has 4 different center. That means it can form 4 chlorinated product. Okay. Similarly, N-pentane can form 3 different chlorinated product. Here chlorination can take place here, and this carbon and this carbon, these are identical position, these are also identical position, and this is one carbon atom. So here we can get 3 chlorinated product, 3 different type of chlorinated product. But in case of 2,2-dimethyl propane, it has 4 identical position for chlorination. Okay, so it will form only one monochlorination product, that is 1-chloro-2,2-dimethyl propane. Okay. Question number 8. A gas decolorizes cold aqueous alkaline KMnO4 solution but does not give a precipitate with ammoniacal CuCl solution. The gas is methane, ethane, ethylene, acetylene. If it is decolorizing alkaline KMnO4 solution, that means it must be alkene or alkyne. That means it must contain any unsaturated. Okay. So saturated reactant like alkanes cannot be the right answer. So methane and ethane, these are not in our option. Then come to option C, that is ethylene, and option D, acetylene. It is of double bonded reactant CH2 ethylene, and acetylene contain one triple bond. Okay, so this ethylene, which contains one double bond, upon treating with alkaline KMnO4, it forms a glycol and it decolorizes alkaline KMnO4 solution. The deep violet color or pinkish color is decolorized. Okay. Acetylene upon treating with alkaline KMnO4 forms oxalic acid COH, and it also decolorizes the KMnO4 solution color. Okay. But upon treating with CuCl and NH4OH, ethylene cannot form any precipitate. Okay. But upon treating with CuCl and NH4OH with acetylene, it forms red color precipitate because it forms cuprous acetylene. So the option D will be the right one. Sorry. The solution does not give precipitate, that means option C will be the right one. An alkene with molecular formula C6H12 upon ozonolysis gives only one product which doesn't reduce Fehling solution. The alkene is reaction 2-hexene, 2-methyl 2-pentene, 2,3-dimethyl 2-butane. When alkene is treated with ozonolysis, it forms aldehyde and ketone. Okay. And between the aldehyde and ketone, ketone doesn't reduce Fehling solution and Tollens reaction. On the other hand, aldehyde reduces Fehling solution and Tollens reagent. Okay, so we have to find out the product of ozonolysis over here, which is ketone. This is in general ozonolysis reaction. In the first step, upon treating with O3, that is ozone molecule, it forms ozonide, and cleavage of this bond forms the desired product. We have 3-hexene, 2-hexene and 2-methyl-2-pentene, 3-dimethyl-2-butene, our reactant. Okay. So this one is first reactant, that is 3-hexene. Upon treating with O3 ZnHCl, it forms this ozonide and our product is propanol. This is aldehyde. So it cannot be the answer. In option B, we are getting ethanol and butanol. These are also aldehyde, so it cannot be the right answer. In option C, we are getting propanol and propanone, one aldehyde and ketone. But the question is asking about only one product, so it cannot be the right answer. But in option D, we are getting only one product, that is ketone, that is propanol. Okay, so it is the right answer, because ketone, that is propanone, cannot reduce Fehling solution. Question number 10. The principal organic product formed in the reaction. So, this is nothing but the addition reaction. We are adding HBr, and it is in the presence of peroxide. Okay, generally in the addition reaction we follow Markovnikov rule, but in presence of any organic peroxide, the anti-Markovnikov rule is followed. So, this is our reactant, and upon treating with HBr and peroxide, we can get this product. So, this negative part of the addendum to be added, that is HBr. So, negative part is Br minus, it will goes to that carbon atom which contain more number of hydrogen, which is anti-Markovnikov rule. Okay, so Br will attack to this position and get. Question number 11. Primary alcohol on oxidation with Cl2 gives primary alcohol. Primary alcohol upon treatment with weak oxidizing agent produces aldehyde, and then upon treating with strong or weak oxidizing agent, it forms carboxylic acid. Okay, so here we can get aldehyde. Okay, and in option A we have this aldehyde butanol. Question number 12. Among the following, which is the Sanger's reagent? Fluorodinitrobenzene, chlorodinitrobenzene, dinitrobenzene, or dibromonitrobenzene? Sanger's reagent, our Sanger's reagent. Okay. It is helpful for sequencing protein, and it undergoes nucleophilic aromatic substitution with N-terminal amino acid group of peptides or proteins. So, this Sanger reagent, Sanger's reagent, 1-fluoro-2,4-dinitrobenzene. Option A will be the right one, fluorodinitrobenzene. Alright. Question number 13. For this reaction, we have to find out C. Okay. This is a sequence of reaction, and we have to find out the last product, that is. So, in the first step, we are treating methyl iodide with lithium. Okay. So, we can get CH3Li, methyl lithium, and upon treating with this acetone, CH3Li is organolithium compound. Upon treating with a ketone compound, it will form an adduct, and upon treating with this hydrolysis, it forms tertiary alcohol. Okay. And you know, tertiary alcohol can be oxidized only in presence of strong oxidizing agent, and that too it takes place via an alkene formation. Okay, so this is our tertiary alcohol. Okay, this is tertiary butyl alcohol. Upon treating with K2Cr2O7, it will form alkene, 2-methyl prop 1-ene. Okay, and then after oxidation it will form acetone. So you can see here number of carbon atom is reducing. Okay, this acetone has one less carbon atom than tertiary butyl alcohol. So option A will be the final answer. Question number 14. Which of the following will favor elimination reaction with cyanide nucleophile? Okay, elimination reaction. So in elimination reaction, there is always formation of one double bond takes place. So option D cannot be the our answer because it has only one carbon atom, methyl bromide. So we'll find out among A, B, C. In option A, we have this bromine atom attached to sp3 carbon atom, and in option B, we have bromine atom attached to sp3 again carbon atom, and option bromine atom is attached to sp2 carbon atom. And halogens bonded to sp2 or sp hybridized carbon atom do not normally undergo substitution or elimination reaction with nucleus. So options cannot be our answer. Find out among A and B. Here this bromine is attached to one secondary carbon atom, but here bromine is attached to tertiary carbon atom, and when there is tertiary Cr3x, elimination reaction dominates. So option B is our right answer. Question number 15. In the following reaction, the end product is what? This is our reactant and we are treating methyl magnesium iodide in presence of ether, Grignard's reagent. Okay. So see, upon treating with methyl magnesium iodide and ether, it will form one acetal, one hydrolysate, acid hydrolysate, it will form hemiacetal. Okay, hemiacetal, then upon a series of reaction form this product. Option A will be the right one. And here a little homework is there for you. You have to draw the mechanism of all these reactions. It's very simple. Question number 16. Among the following, which is a monoamino dicarboxylic acid? Aspartate, arginine, asparaginine or alanine? See, amino acid has the general formula CHR NH2COOH. And if you write the deuterionic form of amino acid is this NH3 plus and CO minus. You have to write NH3 plus and CO minus. Okay. This R group is different for different kinds of amino acids. For aspartate, this is CH2COO minus, and for arginine, this is the R group, and asparagine, this is the R group. Okay. And for alanine, R group is CH3. So you can see in aspartate we have two COO minus group. That means it is a dicarboxylic acid. One NH3 plus group, that means it is monoamino dicarboxylic. Option A is the right answer. Which reaction is used for the preparation of alpha chloroacetic acid? HBZ reaction, NAF reaction, Stefan's reaction or Perkin reaction? This is HBZ reaction, Hell-Vollard-Jalinsky reaction. It is a halogenation reaction taking place at the alpha carbon of carboxylic acid. This is our carboxylic acid, and the carbon atom which is present at the immediate vicinity of our functional group, that is COOH group, is known as alpha carbon atom, and hydrogen atom attached to alpha carbon atom is known as alpha hydrogen atom. Here one of the alpha hydrogen atom is replaced by chlorine atom, and we are getting alpha chlorocarboxylic acid in the presence of phosphorus and chlorine. Okay. NAF reaction is the conversion of, that is hydrolysis of primary or secondary nitroalkane to carbonyl compound, that means aldehyde or ketone. Stefan's reaction is the Stefan's reduction reaction, that is the conversion of nitriles to aldehyde in presence of SnCl2 and HCl. Perkin's reaction. In Perkin's reaction, aromatic aldehyde and acidic anhydride in presence of a base produces alpha beta unsaturated aromatic acid or cinnamic acid derivative. So among these four options, option A will be the right one, that is HBZ reaction. Here we are getting alpha chloroacetic acid. Okay. Question number 18. Which among the following is aromatic? So to be aromatic, a compound must be cyclic, conjugated, planar, and it must follow Huckel's rule. That is 4n plus 2 pi electron should be present there. So in option A, C and D, all these are unconjugated system, and in option B we have a conjugated compound and it is planar, cyclic, it follows Huckel's rule. Remember here n doesn't represent number of rings. Okay, it can be simply 0, 1, 2, 3, etc. So if you substitute n equal to 0 over here, then we can get 2 pi electrons. This ring contains 2 pi electrons. Okay, number of pi electrons. This is our aromatic. And which reaction isocyanate is not an intermediate? Hofmann bromide, Curtius, Gabriel thalamide or Schmidt reaction. Here we have to draw the mechanism of all these four reactions. Okay, and we'll find out whether it is forming isocyanate or not. In first option A, we have Hofmann bromide degradation reaction. Here amide is converted to primary amine and it takes place via the formation of isocyanate R and double bond O. So it cannot be our right option. In option B, we have Curtius reaction. In Curtius reaction, acyl azide is first converted to isocyanate and then upon treatment with R-OH it forms carbamate, upon treatment with O it forms amine, and upon treatment with RNH2 it forms urea derivative. So it cannot be our right option because it forms isocyanate. In option C, we have Gabriel thalamide reaction. Here nucleophilic substitution of thalamide to primary amine takes place. Okay, this is our thalamide. Upon treatment with KOH and RX, it forms N-alkyl thalamide, and then treating with NaOH, it forms primary amine. But it doesn't take place via the formation of isocyanate. Okay. In Schmidt reaction, carboxylic acid is converted to amine and ketone is converted to R-CONHR. Okay. So this is the mechanism. Here we can find that isocyanate. Okay. So and it is the ketone to this product R-CONHR is the mechanism of this reaction. So we can see in Gabriel thalamide reaction, isocyanate is not an intermediate. Question number 20. Isoelectronic point of an amino acid is what? It is very simple. We have four options. Those are pH at which it has maximum positive charge, pH at which it has maximum negative charge, pH at which it has least positive charge, or pH at which it has no net charge. So it is very simple. It is the pH at which it has no net charge. Question number 21. Sucrose itself, which is a non-reducing sugar, it is due to what? See, sucrose is made up of glucose and fructose. Okay. The OH group which is attached to the first carbon atom and OH group which is attached to the second carbon atom of fructose condenses to form one alpha 1 2 beta glycosidic linkage and it forms sucrose. Okay. And you know, non-reducing sugars do not have any ketone or aldehyde group. Okay, this sugar possesses acetal instead of hemiacetal. It possesses the acetal group. Okay, this is the acetal group. In sucrose, glucose and fructose are held together by alpha 1 2 beta glycosidic linkage, where reducing groups are involved. So, the anomeric carbon atom of both the monosaccharides are involved in glycosidic or acetal formation. So, it does not have any free CHO group and it is non-reducing sugar. That means it cannot reduce Fehling solution or Tollens reagent. So, option C, the linkage of both anomeric carbon atom in the acetal form is the right one. Question number 22. Diabetes is detected by testing the urine of a patient, usually with Tollens reagent, Nassler's reagent, Panton's reagent or Benedict's. The urine test may be done in the people with diabetes to evaluate severe hyperglycemia, that means severe high blood sugar, by looking for ketones in the urine. We have to find out the ketones, whether it contains ketones or not. So, ketones are a metabolic product of product produced when fat is metabolized. So, ketones increase when there is insufficient insulin to give glucose for energy. So, Benedict's reagent is as a confirmatory test for ketone. You have to remember that urine test for diabetics patient is done by Benedict's. This is the reaction or changes. Okay. In question number 23, we have what is the shape of ClF3 molecule? Plain triangle, T-shaped or TBP, trigonal bipyramidal or tetrahedral shape. In ClF3 molecule, here we will follow the shortcut formula. Okay, for ClF3, first of all, we have to find out the total number of valence shell electrons. Here, chlorine has 7 and fluorine has also 7 valence electrons. So, all total we have number of valence electrons. So, we will divide 28 by 8. So, we can get a remainder 4 and then again we will divide it by 2. This is our 3 plus 2, 5. Okay, 5, but we have 3 fluorine atoms. Okay, we have 3 fluorine atoms. 2, so 3 plus 5, we have total number of electrons here is 5, but we have 3 fluorine atoms, so there must be lone pairs. The shape will be T shape. Question number 24. What is the bond order of He2 plus? Okay, 1, half, 0 or 3. We will follow the MO diagram here. For He2 plus, the total number of electrons will be what? 1 helium contains 2 electrons. Here He2, that means total 4 electrons we have, but He plus, that means has donated 1 electron. 4 minus 1 equal to 3. So, MO configuration will be sigma 1s2, master 1s1. This is the bonding molecular orbital, the anti-bonding. This is the MO diagram. This is the helium atomic orbital. This is the atomic orbital and the molecular orbital. 1s2, sigma star 1s1. So, bond order has the formula half into Nb minus Na, where Ne is the number of bonded electrons. Na means number of anti-bonding electrons. Okay. Bonding electrons we have 2 and anti-bonding electrons we have 1, 2 minus 1, that is 1, and the answer will be half. Option B will be the right one. Which of the following compound of potassium is known as pearl ash? K2CO3, KNO3, KCl or KMnO4. So, you have to remember that K2CO3, that is our potassium carbonate, is known as pearl ash and it is mainly used for soap, glass and dishware production. Question number 26. Among LASMGDYB, which element will give colored iron? So, all these elements are from lanthanoid series and the color of lanthanoids depends upon number of unpaired electron in f orbital. So, we have to find out the number of unpaired electron in f orbital. Okay. And remember, the half filled configuration and full filled configuration, that is 4F7 or 4F14. F7 or F14 configuration will be colorless. Okay, and beside these two configurations, that means for F7 and F14, all the other configuration possesses any color. So GD2 plus H4F7, that means it is colorless. GD3 plus again 4F7. In SM3 plus we have 4F6, that means 6 number of unpaired electron. It is having pale yellow color. In YB3 plus we have 4F14. Okay, so the correct option will be SM3. When boric acid is heated, finally it gives glassy mass, which is due to the formation of what? HbO2, BO2 minus, B2O3 or H2B4O7. See, when boric acid is heated up to 170 degrees centigrade, it forms metaboric acid, and upon heating up to 300 degrees Celsius, it forms tetraboric acid, and further heating produces boron trioxide or boric anhydride, B2O3, and it is the reason for the formation of glassy. So B2O3 will be the correct option. Question number 28. Which of the following combinations cannot produce a buffer solution? What is buffer solution? Buffer solutions are designed to resist changes in pH when acids or bases are added. You know that. And buffer solutions are of two types. That means acidic buffer and basic buffer. It is a mixture of weak acid and its conjugate base, that is salt of that weak acid, and weak base and its conjugate acid, salt of that weak base. Okay. So in option A we have HNO2, which is weak acid, and in option A also we have NaNO2, that's conjugate base. So it is a buffer solution. In option B we have weak acid and its conjugate base, that is HCN and NaCN, it is also a buffer solution. But in option we have HClO4, which is strong acid. Okay, and its salt we have NaClO4. So it is not a buffer. In option D we have NH3 and NH4 whole 2SO4, which is weak base and its conjugate acid. So it is also a buffer. So option C, HClO4 and NaClO4 is the right option. Next question is, the solubility product of a sparingly soluble salt AB, that means weakly soluble, very less soluble salt AB, at room temperature is 1.21 into 10 to the power minus 6 m square. Its molar solubility is what? We have that sparingly soluble salt AB, it will dissociate like A plus B minus. Okay, and we have the formula KSP equal to x to the power x, y to the power y, and h to the power x plus y, where x and y, these are the stoichiometric coefficient of A and B for cation and anion. Okay, and KSB is the solubility product, S is the solubility. Here we will substitute x equal to 1 and y equal to 1, because here nothing is written, that means it is 1. Okay. So KSP will be S square and S will be the square root of KSP, where the value of KSP, that is 1.21 into 10 to the power minus 6 m square. So S will be 1.1 into 10 to the power minus 3. Which of the following is used as an indicator in the titration of weak acid and a strong base? Bromothiamyl blue, methyl orange, methyl red, or phenolphthalein? See, the correct option will be option number D, that is phenolphthalein, which is a weak organic acid, and upon addition with strong base, it produces a pink color, light pink color. Okay. Question number 31. In an acid base titration, 0.1 m HCl solution was added to the NaOH solution of unknown strength. Which of the following correctly shows the change of pH of the titration mixture in this experiment? Okay, we have 4 graphs. So, here we are given with 0.1 m HCl, that is strong acid, and NaOH, that is strong base. So, the curve for strong acid and strong base is option number B. Okay. This is the pH change upon the addition of NaOH, that is strong base, into strong acid. Question number 32. Based on the first law of thermodynamics, which one of the following is correct? For an isothermal process, Q equal to positive W. For an isochoric process, delta U equal to minus Q. For an adiabatic process, delta U equal to minus W. Or for a cyclic process, Q equal to minus W. You know, the first law of thermodynamics, it states that delta U, that is change in internal energy, equal to Q, that is heat change, plus W, that is work done. Okay. So, delta U equal to Q plus P delta V. Okay, P dV. dV is the change in volume, T is the pressure. So, for isothermal process, you know, temperature is constant, that means dT, change in temperature, is 0. So, delta U, change in internal energy, will be also 0. So, Q will be minus W. So, option A is the incorrect one. Option B, for isochoric process. You know, for isochoric process, V is constant, volume is constant. So, change in volume equal to 0. So, delta U will be, change in internal energy will be Q, because this P dV, it is 0. Okay, it becomes 0, and delta U equal to Q. For adiabatic process, you know, there is no heat change, that means Q equal to 0. So, delta U, that is change in internal energy, W. For cyclic process, what is cyclic process? After completing a series of changes, the system returns to its original state, and it is said to be a cycle is complete. So, for cyclic process, all these terms equal to 0, delta U equal to 0, delta H, that is enthalpy, equal to 0, delta P equal to 0, delta V equal to 0, delta T. So, when delta U equal to 0, that means W will be equal to minus Q, or Q will be equal to minus W. So, option D is the correct option, that is for cyclic process, Q equal to minus W. Question number 32. 2 moles of an ideal gas expand spontaneously into vacuum. The work done is 2 joule, infinity, 0, or none of these. Here the condition is given vacuum. Okay. So, in vacuum, you know that the external pressure equal to 0. So, there is no external pressure acting on the gas, and work done equal to 0, because you know the formula of W equal to P del V, P equal to 0, that means W equal to 34. The heat change at constant volume QB is equal to what? QB equal to, you know, from first law of thermodynamics, delta U equal to Q plus W. So, delta U equal to Q plus P dV, you know that. So, when volume is constant, that means dV equal to 0, delta U will be equal to Q, and it is the condition for isochoric process. Okay, delta U equal to Q. Option A is the right one. Next one is the species which by definition has 0 standard molar enthalpy of formation at 298 Kelvin is what? Br2, Cl2, H2O, or C. See, here we have to find out the element, and H2O and CH4, these are compounds, so which cannot be our right option. So, these are discarded. Okay. You know, bromine, Br2 is a gas, but it is in liquid state at 298 Kelvin temperature. Okay. but chlorine is gas at room temperature. So chlorine Cl2 will be our right option. Question number 36. Which of the following factor affects the heat of formation based on Kirchhoff's equation? Molecularity, temperature, pressure and volume. It is very simple because effect of temperature in heat of reaction is given by Kirchhoff's equation. So option B will be the correct one. CO stretching frequency for tertiary alcohol is what? So here one table is given for primary alcohol, CO stretching frequency, secondary, tertiary and phenol. CO stretching frequencies are given. So you will find out for tertiary alcohol. The molecule which is IR inactive but Raman active is what? HCl, N2, SO2 or protein. See, the molecule which is IR inactive but Raman active, that means molecule which has no dipole moment, zero dipole moment, okay, and it is homonuclear diatomic molecule, that means nitrogen molecule. Here only we have one option which is homonuclear diatomic molecule. Nitrogen will be the correct option. Next question is, the rotational spectrum of a rigid diatomic molecule consists of equally spaced lines with spacing equal to what? Here B is equal to rotational constant. Okay. So for rotational spectrum, energy E equal to J into J plus 1 into B. Okay, J is the rotational quantum number, right? So when J equal to 0, energy equal to 0, E equal to 0. When J equal to 1, E equal to 2B. When J equal to 2, E equal to 6B. When J equal to 3, E equal to 12B, and so on. Okay. So if you plot the spectrum, that means at 2B we have one line, at 4B and at 4B we have another line, and at 6B another line, at 8B another line, and the spacing between all these line is always 2B. Okay. So the spacing is equal to 2B. Question number 40. Acetone shows three important peaks in mass spectrum, that is M by E at 58, 43, 15. Which peak is most intense? That means we have to find out the base peak. This is our acetone, a ketone molecule. So upon treatment with high energetic electron beam, 17 electron volt, we can get molecular ion. Okay, this molecular ion has M by E value 58, right? So then fragmentation occurs. After removal of one proton, that means the hydrogen radical, we can get M by E equal to 57. Upon removal of CH3CO, we can get M by E equal to 15. Okay. And upon removal of one methyl radical, we can get CH3CO plus, which is resonance stabilized. Okay, which is resonance stabilized. So here fragmentation occurs like this. Here this bond is broken. Okay, here homolysis takes place, and we can get a resonance stabilized cation. Okay, which is M by E value equal to 43, and it is the most intense peak, base peak. This M by E equal to 43. Next one is, the nitrogen rule states that in case of a compound has an odd numbered molecular ion, the compound has a dash number of nitrogen. You know, the nitrogen rule states that an odd number of nitrogen atoms will form a molecular ion with an odd mass number, and an even number of nitrogen atoms or non-atal will produce a molecular ion with an even mass number, and this occurs because nitrogen has an odd numbered valence. Okay, and here two examples are also given. In the first example, we have one nitrogen atom, odd number of nitrogen atom having molecular weight 107, that means a odd value. And in the second case, we have NH2, CH2, CH2, NH2. Two nitrogen atoms are there. So, the molecular weight is 60, an even value, okay, an even value. So, the nitrogen rule states that in case of a compound that has odd numbered molecular ion, that means odd molecular mass, the compound has an odd number of nitrogen. Option the right one. Question number 42. In which compound molecular ion peak is not visible? Alkane, amine, alcohol or aromatic compound? Organic compounds that contain alcohols, carboxylic acid, ester, nitrogen and high amount of branching may completely lack a visible molecular ion because they are very unstable. So, in option B we have amine that contain nitrogen atom, and in option C we have alcohol. So, both these compound lack molecular ion. Okay. Question number 43. How many numbers of double bonds present in the compound C8H8O3? So, this molecular formula is for vanillin. Vanillin herbal drug. Vanillin is a herbal drug and it is used for flavoring agent, perfumery, etc. So, it has 4 double bonds. 1, 2, 3, 4. Okay. Question number 44. Mass spectra of a compound shows following peaks at M by E: 86, 71, 57, 43. The compound is butane or 2-methyl butane or N-hexane or 2-methyl pentane. The first option have butane, and butane has M by, the molecular ion peak is at 58. So, it cannot possess 86 and 71. So, it is discarded. 2-methyl butane, also the highest molecular ion peak is 72. It cannot possess 86. So, it is also discarded. In option 3 we have N-hexane. So, this is the fragmentation pattern of N-hexane which produces molecular ion peak at 86 and fragmented ion peak at 6 at 71, 57, 43 and 29. Okay. But in option D we have 2-methyl pentane which has the molecular ion peak at 86 and fragmented ion peaks at 71, 57 and 43. So, this is the correct option, that is 2-methyl pentane. Question number 45. Arrange the following compounds in the increasing order of carbonyl frequency. So, we have 3 compounds: para-methoxyacetophenone, acetophenone and para-nitroacetophenone. Okay. So, this is our acetophenone, benzene containing COCH3, okay, ketone, para-methoxyacetophenone. That means we have para substitution of OCH3 and NO2 group. OCH3 is electron donating group, you know that. So, it donates electrons through the ring. Double bond character of this CO carbonyl group decreases, will be CO minus. So, double bond character will be decreased and bond strength will decrease. Okay, bond strength decreases. So, the force constant K decreases and carbonyl stretching frequency also decreases. On the other hand, in case of para-nitroacetophenone, here inductive effect is dominate over the resonance. Here inductive effect dominates over resonance. Here resonance is prohibited because here 2 electron withdrawing groups are there, NO2 and COCH. Both are electron withdrawing group. So, here resonance is prohibited and inductive effect dominates. Here CO bond strength increases because NO2 electron withdrawing group, and here force constant increases, value of force constant increases, carbonyl frequency also increases. So, the order will be like the stretching frequency will least in case of para-methoxyacetophenone, and then acetophenone, then para-nitroacetophenone. Option A is the correct one. Question number 46. What is the difference in energies of proton oriented with and against a magnetic field of strength 1.5 Tesla? 5.05 into 10 to the minus 27 joule, 4.21 into 10 to the minus 26 joule, 63.8 into 10 to the minus 25 joule, 63.85 into 10 to the minus 27. So here a field magnetic field is given 1.5 Tesla. You know gamma is gyromagnetic ratio, and for 1H NMR gamma has value 42.6 megahertz or 42.6 per 6 hertz. The difference in energy delta E equal to h nu, which is equal to h into gamma into B naught. Have all these values of h, gamma and naught. H is Planck's constant 0.64 joule second. Gamma is having value 42.6 into 10 to the 6 hertz, and B naught is given 1.5 Tesla. That is, this Tesla will be cancelled out, and hertz, that is second inverse, and here second. Both the second inverse and second cancelled out, and have only, so 420.401 into 10 to the 8 joule, which is equal to 4.2 into 10 to the minus 26 joule. Option B will be the correct option. 47. Compound with molecular formula C2H2RCl exhibit two doublets where J equal to 16 Hz in its PMR spectrum. Predict the structure. In the question, it is asking about two doublets. Okay. So the trans structure with the hydrogen atom at trans. So it will produce two doublet, pair of doublet, and in the cis also we can get pair of doublet. Okay. But in transposition for two hydrogen atom, JAB and JB equal to roughly equal to 15 Hz. Whereas for cis pair of for cis configuration we can get pair of doublet where J or JB to 10 Hz, roughly equal to 10 Hz. But in the question we are given with A equal to 16 Hz, it is nearly equal to 15 Hz, so it should be trans configuration. The formula will be option, because in option have a cis configuration also here and C are at the same side, but in option we have a trans configuration. Structure will be friendly adsorption isotherm is what? Friendly adsorption isotherm x by m equal to k into p to the power 1 by n, where x by m is the amount of gas adsorbed per gram of the adsorbent at pressure P, or you can say that x mass of gas adsorbed by m mass of adsorbent. K and n are constant, depends upon the nature of gas and adsorbent. So this is the graphical representation of friendly adsorption isotherm. Here in the x we have taken pressure, and in the y axis x by m. This is the saturation pressure, and at a low pressure it follows first order kinetic. At high pressure, very high over exit follows zero order kinetic. Okay. And this is our adsorption isotherm, moderate pressure. Which of the following compound corresponds to Venter factor equal to dilute solution? KCl, BaCl2, K2SO4, C6H12O6. See, what is Venter factor? Ventov introduced a factor I to express the amount of association or dissociation of solution. So this question is from solution chapter or colligative property. Okay. So I equal to, that is Ventov factor I equal to observed colligative property, that is calculative, divided by normal colligative property, that is experimental. For solute where association is there, I is always less than equal to 1, and for dissociation of solute I is greater than equal to 1, and in case where no association or dissociation of solute takes place, I equal to 1. Okay. So in option A, in all these options, these are dissociative. Okay, these solutes are dissociative. So KCl will dissociate in K plus plus Cl minus. Here two ions are there, so I equal to 2. BaCl2 will dissociate into Ba2 plus plus 2Cl minus. Here 3 ions are there, so I equal to 3. K2SO4 will dissociate into K2K plus plus SO4 2 minus. I will be equal to 3 because we have 3 ions, K plus and SO4 2 minus. In case of C6H12O6, it is a non-ionic solution. It forms a non-ionic solution because it is a molecular compound. Here I will be equal to 1. So in option A we have I equal to 2 will be the correct option. Question number 50. The number of atoms per unit cell in a simple cubic, FCC and BC are respectively what? So we have to calculate number of atoms per unit. In the simple cubic crystal, we have all the atoms at the corners only, and you know contribution of corner is 1 by 8. So 8 into 1 by 8 equal to 1. For FCC, face center cubic lattice, we have all the atoms at the corner and center of face. Corner has contribution 1 by 8, 8 into 1 by 8, and the facial contribution 1 by 2, 6 1 by 2. So it will be equal to 1 plus 3 to 4. For BCC, body center cubic lattice, we have all the atoms at the corners and at the body center, center of the body, and you know body center has complete contribution of 1, so it will be like 8 into 1 by 8 plus 1 into 1, 1 plus 1 will be to 2. So 1 4 3. So the correct option will be 1 4 2. Option A is the correct one. Question number 51. Which of the following relationships which or are not true? Most probable velocity equal to square root of 2 RT divided by M, PV equal to 3 by 2 KT, Z equal to PV by nRT, or average kinetic energy equal to half KT. This question is from gaseous state. Okay. So you know this most probable velocity is equal to 2 RT by M square root. This is correct one, and Z compressibility factor Z equal to PV by nRT is also correct. But in option B and D we have incorrect statements like average translation energy equal to half KT, not average kinetic energy, and average kinetic energy equal to 3 by 2 KT. PV is not equal to 3 by 2 KT. So option B and D, these are incorrect. These are not true. Question number 52. 2 moles of ideal gas expands spontaneously into vacuum. The work done is 2 joule, infinite, 0, or none of these. Look, this is from thermodynamics. So in vacuum, external pressure is equal to 0. So there is no external pressure acting on the gas. Work done W equal to P into dV. Work done will be equal to. Question is the repeated one. 53. Mean free path lambda is equal to what? Lambda is directly proportional to P by T by P, lambda equal to B by T, or lambda is directly by theta. See, mean free path lambda equal to C bar divided by Z1. C bar is the average velocity and Z1 is the collision number. So collision number as the expression root 2 pi d square c bar rho. So lambda will be equal to 1 by root 2 pi d square rho, and if rho equal to n by v, lambda will be equal to p by root 2 pi d square n, and if rho equal to p by kt, lambda will be equal to kt by root pi d square lambda. Okay. So you can say lambda is directly proportional to temperature and inversely proportional to pressure. So the option which is lambda is directly proportional to T by P, that option B is the correct one. And this question is from gaseous state. The transport number of H plus is 0.230, 0.430, 0.6 or 0. The transport number of H plus ion from the data obtained by moving boundary method using CdCl2 as the indicated electrolyte are: concentration of HCl solution is 0.1 n, and mass of the Ag deposited in the colorimeter is 0.1209 gram. Moment of boundary is 7.50 centimeter, and cross section of tube is 1.24 centimeter square. So using this data, you can calculate the transport number of H plus, which is the formula LAC divided by 1000 Q. L is what? L is the length of migration, and it is given 7.50 centimeter. A is the area of cross section. Small a is the area of cross section, that is 1.24 centimeter square. C is the concentration, that is 0.1 n. Q is the charge passed, okay, or equivalent of Ag deposited. This is equal to 0.1209 divided by 108 Faraday. Okay. So TH plus will be LAC divided by 1000 Q as the result 0.83. So option D will be the right one. Third law of thermodynamics provides a method to evaluate which property? Absolute energy, absolute enthalpy, absolute entropy, or absolute free energy. See, third law of thermodynamics is concerned with the limiting behavior of system as the temperature approaches absolute. Okay. So the third law tells us about the completeness as it describes the condition of zero entropy. So option C is the correct one, absolute entropy. Next one is 1 mole of which of the following has the highest entropy? Liquid nitrogen, hydrogen gas, mercury, or diamond. The entropy. What is entropy? It is a measure of randomness of a substance. Greater the randomness of the molecule, greater is the entropy. From all these given options, we have hydrogen gas. So hydrogen has less molar mass, and it is in the gaseous phase. So it has more randomness. The entropy will be highest in hydrogen gas. Which of the following is true for the reaction H2O liquid is in equilibrium with H2O gas at 100 degrees centigrade and at 1 atmospheric pressure? Delta S change in entropy equal to 0, delta H equal to delta S, delta H equal to delta U, or delta H will be equal. You know, for this equilibrium H2O liquid to H2O in gas, you know, for any equilibrium state, delta G, a change in free energy equal to 0. So from thermodynamics, this relationship exists like delta G equal to delta H minus T delta S. When delta G equal to 0, delta H will be equal to T delta S. So option B will be the correct one. Question number 58. The temperature of the system decreases in an adiabatic compression, isothermal expression, isothermal compression, adiabatic compression. You know, for isothermal condition, temperature is constant, and for adiabatic, there is no heat change. And for adiabatic compression, temperature increases, and for adiabatic expansion, temperature decreases. The temperature of the system decreases for adiabatic expansion. Option D. Next one is a metal M is the first group of the periodic table. Metal M is in the first group of the periodic table. What will be the formula of its oxide? MO, M2O, M2O3 or MO2? Look, metal is in the first group, so it has valency equal to 1, right? And in oxide, you know, O2 plus valency equal to 2. So the formula will be M2O because valencies are exchanged. Question number 60. Which of the following set of elements is written in the order of their increasing metallic character? The metallic character of an element increases as we move down along the group in the periodic table and decreases along a period. Okay. So in option D, have beryllium, magnesium and calcium. So here increasing order of metallic character is same. Lattice energy is directly proportional to interionic distance, directly proportional to Born exponent, inversely proportional to interionic distance, or inversely proportional to Avogadro's number. What is lattice energy? The amount of energy required to form 1 mole of a solid lattice from its gaseous under standard condition, or it can be stated like it is the amount of energy required to separate a 1 mole of solid ionic compound into its gaseous. So lattice energy is always a positive value, and higher the lattice energy, more stable the compound, and it cannot be calculated directly. So we use Born-Haber cycle to calculate the lattice energy. Lattice energy has the formula K into 1Q2 divided by R. Okay. So the energy between the two ions is directly proportional to the product of their charges. Q1, Q2 are the charges, so is directly proportional to the product of their charges and inversely proportional to the distance separating them. This is the distance, and K has the value equal to 0.99 into 10 to the power 9. So the option which one is correct is inversely proportional to interionic distance. The correct order of dipole moment is, and we are given with 4 type of molecule like CH4, NF3, NH3 and water. See, here first we have to draw the structure of all these molecules. CH4 has perfect tetrahedral structure, so here dipole moment mu is equal to 0. In case of NH3, you know, nitrogen is more electronegative than hydrogen, so here mu is additive. Okay, mu is additive, and the resultant dipole moment will direct in this direction, and mu will be equal to 1.47 dBi. In NF3, mu is subtractive because fluorine is more electronegative than nitrogen. Okay, so the resultant dipole moment mu will be equal to 0.24 dBi. In water, mu is again additive and the resultant dipole moment will act in this direction and mu will be equal to 1.85 dBi. So the order will be like first is CH4 has the least dipole moment, and then this NF3, then NH3, then water. Okay, option A. Next one. In which of the following cases the covalent character and the melting point order are the same? Covalent character is guided by Fajans rule. Okay, covalent character is guided by Fajans rule. And melting point depends upon the ion-ion interaction, that is F, and F is directly proportional to Q1 Q2 divided by R square. Q1 and Q2 are charges. So according to Fajans rule, smaller the cation, higher the charge of the cation, obviously more covalent character. And if you look these 4 options, then for each option we are given with same anions, so we will consider only cations. In option A we have Be2 plus, Ca2 plus and Ba2 plus. In option B, we have Na plus, Mg plus and Al3. In option C, we have Mg2 plus, Sr2 plus, Ba2 plus. And in option D, we have Na plus, Mg2 plus and Al3. In option D, the covalent character increases. Why? Because size is decreasing. Here charge is increasing and size is decreasing. So size is decreasing, that means covalent character is increasing. Okay. And the melting point also increases, because as the charge of the cation and anion increases, force of attraction increases. So bond strength increases and melting point increases. And option B, in option B, here Na plus, Mg2 plus and Al3 plus are there. So here size is decreasing, that means covalent character is increasing, but the melting point is decreasing, because NaCl is ionic whereas AlCl3 is a molecular compound. So option D will be the correct one, where covalent character and melting point are both are increasing. Which of the following has T shape? And we are given with 4 type of molecules. Okay. So here I have followed a shortcut rule. Here you have to calculate the total number of valence electrons. Okay, first of all, you have to calculate the total number of valence electrons from the electronic configuration of all the atoms involved. Okay, then you will calculate total number of electron pair. How? If the total number of valence electron lies from 1 to 8, then you have to divide it by 2. And if it lies from 9 to 56, then you have to divide it by 8. It is 22 for I3 minus. So I will divide it by 8 and we are getting 2. Again 6 is divided by 2 and we are getting 3. The total number of electron pairs will be 5. Okay, but we have I3 minus. Okay, the surrounding atoms are 2, so bond pair should be 2, and the remaining 5 minus 2 will be the lone pair. Okay, so hybridization will be what? sp3d, because we have 5 bond pairs. Okay, 5 electron pairs, so hybridization will be sp. Geometry will be trigonal bipyramidal, but due to the presence of 3 lone pair, we have lone pair repulsion and lone pair bond pair repulsion. So the final shape will be linear. Okay. Likewise, NH2 minus has band shape or V shape. BeF2 has linear shape and H2O has band shape or V shape. So we can conclude that none of these compound has T shape. Okay. And you will get grace point for this type of question. PF3 is very reactive because bond angle FPF is 90 degree. Axial bonds are longer than equatorial bonds. It is sp3d hybridized. None of these. See, the hybridization of PF3 is sp3. So option C is incorrect. Geometry is tetrahedral. Okay, and shape is trigonal pyramidal. And here bond angle is 96.3 degree. So it is also incorrect one. And here nothing like axial bond or equatorial bond. So option B is also incorrect. So right option will be none of these. The molality of pure water is what? 100 m, 55.6 m, 50 m or 18 molar. See, molality has the formula number of moles of solute divided by mass of solvent in kg. You know, density of pure water is 1 gram per ml. So density as the formula mass by volume. So you can calculate mass from the formula of density. Mass equal to density into volume. That means 1 gram into 1 gram per ml into 1000 ml is equal to 1000 gram. So mass of water is 1000 gram. So given mass is 1000 gram and molar mass is 18. So number of moles of solute will be 55.55. Okay. So molality will be 55.55 divided by 1, which is equal to 55.55, roughly equal to 55.6 molar. So option B is the correct one. Alright. Which one of the following 0.1 m aqueous solution will have the lowest freezing point? K2SO4, NaCl, urea or glucose? See, any type of colligative property like depression in freezing point, elevation in boiling point, osmotic pressure, relative lowering in vapor pressure, etc. All these colligative property depend upon Venter factor I. Okay. So, depression in freezing point has the formula delta Tf equal to I into Kf into m, where Tf is the freezing point of the solution, okay, and delta Tf is the depression, okay, depression in freezing point. I is the ionization or Venter factor, Kf is the cryoscopic constant, and m is the molality. So, now we will calculate the Venter factor. For K2SO4, K2SO4 will dissociate like 2K plus SO4 2 minus. So, here total number of ions equal to 3 and I equal to 3. For NaCl, it will dissociate like Na plus and Cl minus. So, I equal to 2. And urea and glucose are molecular compounds. Here no dissociation is seen. So, here I equal to 1. So, you can see in option A, here I equal to 3, that means larger depression in freezing point, lowest freezing point is observed in K2SO4. Question number 68. Among the following species, the one having the highest bond strength is what? O2, O2 plus, O2 minus or O2 2 minus. So, here we will draw the MO diagram, or simply you can write the MO configuration. Okay. Here I have written all the MO configuration for O2, O2 plus, O2 minus and O2 2 minus, and then we will calculate bond order. Okay. Bond order, formula of bond order is equal to half into Nb minus Na, number of bonding electrons minus number of anti-bonding electrons. So, for O2 it is 2, for O2 plus it is 2.5, and for O2 minus it is 1.5, and O2 2 minus it is 1. And you know, bond order is directly proportional to bond strength. So, you can see for O2 plus the bond order is 2.5. So, it has the highest bond strength. 69. Halide ions are reducing agent. Which one of the following is their correct sequence in the increasing order of their reducing power? See, elements having high electronic repulsion will easily accept electrons, thereby gaining stable octet configuration, okay, and reducing electronic repulsion. So, having high reducing power, which has high electronic and have high reducing power. Okay. So, moving down the group, atomic size increases due to the increase in number of cells. You know that number of cells increases down the group and atomic size increases. So, electrons are spread out because they have now more space. So, electron density goes on decreasing. So, inter-electronic repulsion decreases, electronic repulsions decreases. So, you can see F minus, the smallest size. Okay, here significant electronic repulsion can be seen. So, strongest oxidizing agent, it is the strongest oxidizing agent and weakest reducing agent. And on the other hand, I minus is strongest reducing agent. So, the correct order will be I minus is greater than from B, R minus is greater than from L minus is greater from F minus. The last one is, which one of the following is a pseudo halide? Cn minus, ICl, IF5 or I3 minus. See, pseudo halides are fake halides. Okay, so their chemistry bears some resemblance to true halides like fluoride, chloride, bromide, iodide. And examples of pseudo halides are Cn minus, cyanide ion, N3 minus, azide ion. And these are generally weak Lewis base that bear a formal charge -1. So, among these options, we have Cn minus as our pseudo halides. Okay. So, this was the last question, and now it's your turn to practice more questions like this. If you have any doubt, then do let me in the comment section. Thank you so much.